Hey guys, welcome back to geometry. We're going to look today at the area of a circular sector. Now, first off, what is a circular sector? Basically, if you consider the circle to be a pizza, a circular sector is a slice of that pizza. Okay, you have these two radii coming from the center, going out to the edge of the circle, the circumference, and then this circular arc goes from this radius to this radius. This shaded region in the middle, that is a circular sector. Now, there's a couple different ways that I can find the area of that circular sector. The simplest way to do it, though, requires two things. Number one, you need the central angle in radian measure. Number two, you need the radius of that circle. You have those two things, you can find the area of that sector. Okay? Now, if you have the angle in degree measure, there's a different approach that you can use. It's a little bit more complex, so it's best just to stick with this. So if you have the angle given to you in degree measure, you need to convert it to radian measure. Now, we have this circle here. We have this circular sector. We want to find the area of that circular sector. So here's what we're going to do. We're going to take this formula. We're going to say that our theta is 5 pi over 8. Our radius is 4, and we're going to sub them in. So the area of this circular sector is 1/2 times 5 pi over 8 times the radius, which is 4 squared. Now, multiplying fractions, we can multiply straight across, okay? So 1 times 5 pi is going to be 5 pi. 2 times 8 is going to be 16. Now, 4 squared is also 16. So if I want to multiply this fraction times this integer, I'll put this integer over 1, multiply straight across. Now, the good news here is those 16s are going to cancel out. And we get we get exactly 5 pi. Now, if I do want a decimal approximation of that answer, then we need a calculator. So I'll do 5 times. Now, if you're using one of these calculators, pi is not easily found, okay? On this one, it's right above the exponent key, okay, in yellow there. So I have to press the second to get to it. And 5 times pi is about 15.708. And they don't tell us what units this radius is, so we'll just say square units. Okay, now let's take a look at a slightly different one. We did one with a picture, let's do one without a picture. Okay, find this area of a circular sector with a central angle measuring 7 pi over 6 and a 9.4 meter radius. Okay, so this 9.4 meters, that's your R. This 7 pi over 6, that's your theta. So we're going to take those and sub them into that formula. 1/2 times theta times the radius squared. So area equals 1/2 times 7 pi over 6 times 9.4 squared. So multiplying the two fractions, multiply straight across. 1 times 7 pi is 7 pi. 2 times 6 is 12. And I need to multiply that by 9.4 squared. Now, I don't know what that is off the top of my head, so I'll do 9.4 squared and get 88.36. Now, if I want to find an approximation, I'm going to put this into the calculator. So I'll do 7 times pi divided by 12 and get about 1.8. And then I'll multiply that by 88.36 and get about 161.928. Okay, now this time they do give us that it's meters, so this is square meters. Okay, now as I mentioned before, if they give you the angle in degree measure, you have to do things a little bit differently. Okay, so we want to find the sector area given that the central angle is 125 degrees and the radius is 11 inches. So what we're going to have to do first with that 125 degrees is convert it to radian measure. Now the trick for that, like we did last week, is we use a proportion. Okay, so we'll do theta that we want in radian, we'll put that on top, over 125 degrees is equal to, now we want it to be in radian, so we put the radian pi on top, divided by 180 degrees. Now these two are equivalent. 180 degrees is halfway around the circle in degree measure. pi is halfway around the circle in radian measure. So this fraction is equal to 1. If I multiply both sides by 125 degrees, okay, that will give me what the measure is in radian. So these 125s will cancel, and I'll have 125 pi over 180. Now I want to reduce that as much as I possibly can. So let's see, that's going to be divisible by reduce all the way down to 25 pi over 36. Okay, now this is the theta that I want to use. This is the one that I want to use in that formula. So again, that circular sector area is 1/2 times theta times the radius squared. Now that theta has to be in radian measure. If you use degree measure, you're going to get very crazy answers that aren't going to make any sense. Make sure you use radian measure. So 1/2 times 25 pi over 6 times 11 squared. So multiply straight across. 1 times 25 pi is 25 pi. 2 times 6 is 12. Times 11 squared is 121. Okay, put it over 1. Multiply straight across again. 25 times 121. And your area is 3,025 pi over 12. Okay, now that fraction is not going to reduce, but if we do want a decimal approximation, we can go to the calculator, do 3,025 times pi divided by 12, and get about 791.943. And that is square inches. Okay, and there we go. Now let's do one more using degree measure. Okay. So if it's in degree measure, the first thing that we're going to have to do is change that angle to radian. Now there's two ways we can do that. One is with the proportion that we had down low. The second is using a conversion ratio. So I take the 204 degrees and I'm going to multiply it. Now it's going to be either pi over 180 degrees or 180 degrees over pi. What I want is whatever measure I want, whether I want radian or whether I want degree, whichever one I want, we put that one on top. So since I want this to turn into radian measure, I'll put pi on top of 180 degrees. And when I multiply straight across, I get 204 pi over 180. Okay, the degrees cancel. So I'll take 204 divided by 180, and I will reduce that fraction, and I'll get 17 over 15. 17 pi over 15. So this is my angle in radian measure. So now I'll take this, and area is equal to 1/2 times 17 pi over 15 times 7.2 squared. Okay, now multiply straight across, and we'll get 17 pi over 30 times, I don't know what 7.2 squared is, so 7.2 squared, and I get 51.84. Okay, so now I'll take that, take it to the calculator one more time, and get an approximation. So 17 times pi divided by 30 times 51.84. And we get about 92.287. And that is square centimeters. Okay, and there we go. So the formula is area equals 1/2 theta times the radius squared. The catch is that theta, that central angle, absolutely positively must be in radian measure. If it's not in radian measure, you cannot use this formula. There's another approach that you have to use. The best thing you can do, though, if you're given that angle in degree, just convert it to radian. And then you've got a very simple formula to work with. Okay, guys, there's an assignment in Teams. If you have any additional questions, please make sure you email me or chat me through Teams. One way or another, get your questions answered. Good luck.